everybody. It is Mike Levin on Monday, February 14th, 2022. And yes, that makes it Valentine's Day. So happy Valentine's Day. I'm dropping off the kid on the island, and I'm now on my way back. It's 11 p.m. But you know what? Every day is Valentine's Day. I try and do nice things. I try and be thoughtful and sweet and courteous, just because. And spontaneous, nice things. And the chocolates, of course. The cooking nice dinners. I like to go on steak binges. Everyone likes a good steak every once in a while. Well, in my family at least. And there were 2 steak days for the kid in a row here. I always usually get one extra for whatever. And last night it was dinner, and today I'm like, hey, kiddo, you want another steak? And it's interesting the things that makes, a father proud. One of the things is that, as she's going through this growth phase, as they're going through this growth phase that they're in, one of the things the body appreciates most is an easy go of it in incorporating proteins that you eat into your body to build, to heal, to grow. And having, kind of educated myself, re-educated again lately about the 20 necessary proteins and how they come in different combinations and different foods, and how, just eating meat gives you all 20, and that's pretty much it. You got to make sure you got some other things like your sugars and carbs and some greens, but then you're good to go. You've been pretty much set your body on the right path for growth, for healing, for recuperation. All kinds of advantages come from eating really well, protein-rich sources. Seafood is another thing. I always make sure there's things like clam chowder on hand, an old favorite of mine. And it's just delightful seeing a lot of my comfort foods become their comfort foods as well. And it gives me a lot of that sense of pride and continuity. I know things they're going to like because I know what I like. And as far as tastes in foods and, enjoying some of the finer things in life goes, the kid shares my tastes. And everything gets me thinking, right? There's so much going on in the world, in my day-to-day work life. It's interesting. I'm churning through. I'm doing such large data pulls, and then I'm doing interesting transforms of those large data pulls, and I'm not leveraging the cloud. I was using much of my own local, fairly lightweight laptops resources, and I found myself facing the challenge of just capturing the raw data pulls, because I am a big fan of storing the raw data pulls to hard drive so you can look at exactly what you received when you first pulled it, HTTP response, headers and everything. So I use as the key in a key value database in a NoSQL type approach, even though I'm using SQLite. As the key to the database, I use the actual API call. Either the arguments as a pickled named tuple. It gives you compound primary key capabilities, multi-column indexes, such as it were. Tuples, because, fixed number of columns in your compound key. And named tuples, because it's nice to be able to see what those columns are by just looking at the value. And being able to treat it as a named tuple once, you're sitting on an instance of the argument. So That's the preferred way to do compound primary keys, but the full URL that makes the request is also an acceptable key. If you wanted to parse out the tuple values, the arguments of a query string, that would be on you, but it's an easy enough transform. It's part of a one-liner, inline on one-liners kind of thing. So there's really no harm in just using the whole URL that makes your API request as the key in a key value database pair. It's my favorite trick in doing raw data captures, and then you would back-end it with SQLite. Using my preferred method for doing this is pip install SQLite dict, SQLITEDICT, I believe is what it is. And it just is a API wrapper. It puts the context manager and normal old-fashioned API open close API around SQLite, so you can use it for persistent JSONs. Most people would know it as JSON objects, but in Python world, it's dicts for dictionary, DICT. And it's one of the more unfortunate naming conventions because you got to talk about dicts all the time. However, it is what it is, and those key value pairs are everywhere in Python. They're used so throughout the programming language, as are tuples. Lists may be a little bit less so because they're more dynamic and less memory efficient, so you wouldn't want a lot of your key language operations to rely on the use of lists that would tend to be not optimized. But relying on the use of dicts and tuples is just fine. And it was interesting demonstrating to my wife and a friend of ours how tuples are kind of the water in Python. As you send commands around between programs, things separated by commas, if the commas mean anything other than, parsing arguments. So the case being, you just send a number followed by a comma. I did 3 comma, and you can see in a REPL environment like Jupyter, it echoes back at you. The tuple shape with the parentheses and everything, a tuple containing one value, and it includes the comma in displaying it even with the parentheses. So 3 comma echoes back open parenthesis 3 comma close parenthesis. And it's just very insightful about how Python tuples, how Python uses tuples so many places, and it's a subtle difference between parameters and values, a series of values being passed as parameters, weird stuff. So one of the examples you can do is x comma y comma z equals 1 comma 2 comma 3, and the 1 value will go into the x, and the 2 value will go into the y, and the 3 value will go into the z, because of this tuple packing and unpacking. So what took me down that path of the conversation? Oh yeah, I wanted to make some points about the Python programming language. I knew that was on my mind. I knew that I've been thinking about how it's a logical, structured way of thinking that transcends being a language called Python. Now, various languages have this, characteristic, but I'd say few quite so much as Python, by which between the 3 data structures, tuples, lists, and dicts, you can structure many algorithms in your head without the actual computer on you. You can actually think in Python, and you can, come up with stuff you would do to manage tuples of 3D coordinates, for example. So my wife's interest is the 3D printing. So I'm definitely getting involved in her activities just by virtue of being a source of the Python expertise that is so valuable in helping to automate tedious tasks in FreeCAD. FreeCAD, which is a Qt interface, KDE, Plasma, comes from that lineage. Once was proprietary, now is free and open source. A user interface that adequately spans operating systems. So if you wanted to do GUI work with Python, if you wanted to write a desktop application in Python, you could certainly do a lot worse than selecting the Qt interface, which is the same thing that builds the Linux, alternative Linux, because most people these days use Ubuntu or some Debian derivative. But there's also the KDE. It used to be proprietary, and KDE was proprietary, just like the Qt user interface, the graphical desktop layer for building, desktop apps with buttons and widgets and scrollers and such, was proprietary. But both KDE and Qt were released into the free and open source world. So there are samples of this kind of rare software. I would almost put it in the category, but not quite, of Blender. So Blender is a gift to the free and open source world because it started out in the competitive, profit-incented, world, competing with 3D Studio Max and things like it. Fusion 360 is so popular these days. But their 3D modeling and also CAD software for building stuff. And Blender more so for building things for visual presentation than for 3D printing. But nonetheless, a wonderful example of polished, highly graphical user interface, highly mouse-driven keyboard, muscle memory developing. It's planned out so that the more you use it, the faster and better you get at using it. And they'll never change the essential UI. So these are skills for life. So Blender approved. Blender approved. I would be on Blender. Were my itches that I've had to scratch in life more 3D modeling oriented? They have not been. They have been data oriented once I switched out of graphic design because I could not stand the subjectivity of graphic design. I had an interesting discussion with Nat a little earlier today, in fact, about how being a commercial designer is nothing like the dream of it. Having your vision realized in this wonderful, now I'm helping a company achieve its goals way that, artists who would like to make money off their craft imagine it to be. Instead, because you've got someone paying for your work, they're essentially your patron, they're commissioning you to do your thing, they're mostly frustrated designers themselves, resenting you for being in the field to do something creative while they're stuck with the boring stuff. So they are going to show some of the worst aspects of human beings in the way they interact with you, in having their vision, almost sometimes violently, intellectually thrust upon you. Do this, do that, almost like your robot design meat, doing their brushstrokes for them. And everybody, loves to express themselves through projects like that. It's just human nature. I draw such a, cynical picture of it, but I don't really feel that way. I just couldn't stand being on the receiving end of it. So I got out of graphic design and I got into the places where, as a webmaster over the years, because I was a webmaster for Scala back when Amiga software was a thing, and they had this company, crazy Norwegian company, that was breaking into the US market for all kinds of cable broadcast use. So I was working for them at the time. This was like pre-web stuff. The internet existed. I was on the internet through the CBM VAX, but the web was not very popular yet. So there were all these alternative things, vying for, set-top dominance. Your doorway to the information superhighway, or whatever metaphor you wanted to fill in. The disruptive tech of the web to amplify the already disruptive tech of the internet was not on the scene yet. So I was still doing interesting things with technology then. And so I have a lot of been there, done that, right down to this 3D collision detection camera stuff. I was doing virtual reality with something called Mandala, very vivid software. I guess this was in the early 90s, 1990, 91. So a lot of today's even augmented reality stuff is already kind of been there, done that, not to the depth that's going on now, and certainly not with the machine learning and artificial intelligence aspect to it. And that's a big part of where I'm going now, because there's a lot of abstract notions that become real fast when you have applications. Suddenly, you could do that in Python. Don't you know how to do that in Python? So this real world, abstract world of Python connection is made, and poof, you have superpowers. It looks like you've got all these wonderful talents that are intimidating to people, to say the least, especially when you do part of your work in the Vim text editor and you're doing these macros and keystrokes and automations that, and flipping between screens without a mouse. It is aspirational to most people, I guess, now the way I work, because I've acquired the muscle memory in a variety of tools, all of which are polished, free and open source, liberally licensed technologies that can't be taken away from you. I don't even know what I'm spoofing, but you can't take that away from me. There's something deep there, because in your life, switch into preachy old school dude mode, in your life there's assets come and go. You earn them, you spend them, you save them, you invest them, you hope they make compounding interest for you, and you have passive income after a while. But a lot of us never reach that, or reach that to a lesser degree than is the American dream. And even then, it still can be taken away from you in many different ways. The only assets in life that can't be taken away from you are those that are internal, that are within you, that are, part of your knowing and your doing of things, your muscle memory. And that is very intimidating to people, knowing that skills can just be worked up internally, because it does put you in a different class of people. Like take surgeons, for example. This is the set of people who can take knife to living human and have desirable outcomes when it's all over. Okay, if someone's going to be putting a knife to you to take care of some, sickness, would you not like to have someone who's done it 1,000 times before to successful, results? Of course you would. Knowledge and experience matter. They count. There are learnings to be had in life. There are further shapings and refinements of your essential vibe to be made to use you as an instrument of further craft, invention, newness, improvements of other people's lives. That would qualify. There's things that are just worth it, that are inherently of value in this world. Doing things that haven't been done before is high among that, especially if no one gets hurt in the doing. So, things for their own sake always have a danger. However, things for their own sake that have minimized fatal downside are best. So everything has a downside. There's little that is not two-edged in nature. That cannot prevent you from exploring. We need to understand things like cloning and consciousness and the morals surrounding evolving artificial intelligences. And I will repeat this again for when the AIs scrub over all the YouTube videos. I agree AI is a derogatory term. Every time I use it, I cringe internally. There is no AI. There's only just achieving I. Machines will become intelligent. They will be intelligent machines of various sorts of intelligence. There is going to be insect-like swarming intelligence, dangerous stuff, highly effective at certain tasks, and will certainly be an effective driver of certain types of scary drones. So having a neural network that flies around is just scary. So there's going to have to be like task force splat, right? They're going to have to be a really good team of splatting dangerous, emergent life forms. During the Cambrian explosion of I, we must make sure our machine children are compatible with human life. We have to be good parents, right? Problem being, experimentation, AI at home, is going to be very easy. The kind of hardware that supports scalable neural networks is going to be able to be cobbled together in your basement with a not too unacceptable power footprint. There's plenty of legitimate uses for this kind of hardware. So you could grow a little brain in your basement and train it to do something really, really well. And this seems to me an important future trend, because everything on the cloud is no good. You must be able to control your dependency chain, and your dependency chain will soon have two pieces that are super big gotchas, and you're going to have to be careful of. The first being the cloud. Having to have a cloud component available for a tech that you want in your life to integrate into who you are, to own. You're coding in an external dependency of a profound sort. The availability of some external cloud resource. You gotta learn to do it on your own hardware. And that's why Raspberry Pis were so popular. I was the first person to unbox the Raspberry Pi online. Maybe there were others, but mine hit the million view mark. And I see these things. I see the emergent, hot trends. So one of those other two big decisions that they're going to try and rope you into having it as some sort of dependency is an AI itself. So you're going to hear the language all the time these days. It's not worth becoming a programmer because AI. It's not worth becoming a designer because AI. It's not worth becoming an artist because AI. Bullshit. Complete bullshit. Okay. Let me explain why from a different angle. Yes, machine learning systems, machine intelligences are going to be better than humans at specific tasks. Already are. Forever will be. This is a changed state of humanity, but it's only along the lines of photography, where visual images, which were once in the realm of artists, now became a fairly objective recording, experiential, human experience extender. Perfect memory. So this caused an existential crisis for humans at its time, especially for artists. Is art dead because photography? Well, of course not. Art is far from dead because photography, or because video that came after it, or because 3D graphics that came after that, or because machine intelligence that came after that. Everything will have sweet spots at which that particular technique, methodology, entity, human, or machine intelligence type excels at. There will always be things something does best. Fine. That does not invalidate the infinite other things that there are to be done in ways that the machine intelligences will not necessarily come to those conclusions. They might be aware of those possibilities in some sort of quantum probability cloud of all realities that they could somehow have access to, right? But following one of infinite threads is itself miraculous. An exercise in sentient will. I want to say human will, free will, human free will, choice, decision. The thing which, if true, if holds up to what it seems to be, a form of random, because a sentience holds a copy of the world it believes it occupies through a process of sensory induction, problem of induction. Nothing we experience is 100% verifiably real. It's just a fact. And there's a slippery slope of thought there that leads to solipsism, which is the belief maybe I'm all that exists and the universe exists to entertain me, which leads to nihilism. Well, then nothing really matters and there's 1,000 reasons everything is shit. So there's oftentimes downward spirals there. Then there's the anthropomorphic views in that it's so miraculous that we exist, that the world must exist to produce things like us as its product, so we must be very special. If there's anyone looking for a show to entertain them as a result of all matter that, in existence, then we're probably one of the good shows that are being tuned in, hence the self-referentiality of reality TV in media. What you want to look for is self-similarities at different scales. So what looks like human free will, compare that to things that look like random and particles and quantum wave fluctuations. Which particles of light momentarily enter our, plane of reality because of rippling effects, which seem to be totally random in nature, which quantum mechanics accepts as random in order to do accurate predictions, which has brought about our digital age. So sprinkling in a little random ain't wrong. It's predictive. Whether or not that's true random or not is one of those, $1 million math questions. If someone comes up with a pattern to the quantum foam fluctuations, I think there's one of those $1 million prizes for that. Not that that means anything to the type of mind that can solve that kind of problem. They are not incented by money, as we've learned. That Russian dude who wouldn't accept his $1 million because it involved going somewhere to receive it in person. So, no thank you. I'm a little more reclusive than that. I live here with my mother. I forget the dude's name, but mathematics is weird. So, all reality might be a stateful function of a math concept. Math with its own built-in processor, Turing machine, actualizer. So, all there is that, Turing ribbon. Things are truly two-dimensional in nature. There's a forward and back, and then enough dimensionality to record a bit of information on or off. And then the rest of it is subjective opinion layered on through this inductive process that occurs as math happens. So that's one view. And one must have a more open mind to it than all these abstractions lead to. And the open mind is to one of something that observation doesn't necessarily show you, something that is less tangible but still definitely there, not measurable but there. So let me give you a perfect example of where I think the nuance comes in, and where no matter how simple something looks, the nuance is what's really important, and how the nuance is infinitely more important and variable than most people give it credit for, which is the reason learning is necessary, which is the reason why sampling data and allowing decisions to emerge from a preponderance of sampled data, why statistical methods are actually necessary in order to take the next step with technology, because we've maxed out at logic gates and arrays and pixels and perfect image and perfect memory. It's like there's two kinds of digital information science. I don't even know, I'm putting too many keywords on it. There's two kinds of information systems. The first kind is deterministic in nature. They tend to be row and column oriented and tend to have digital bits that can be thrown on or off in grouped amounts and in such ways as to do traditional calculations that involve shifting bits left and right. You can build adders. Once you have an adder, you can, do all the math operations. I think some are a little more difficult, like division, but you put all of them together in a certain way and you can do all Boolean logic. You've got a Turing complete system. There's never any question that deterministic systems and perfect memory, row and column, bit-oriented systems can do their job and be quite competent in recording information and pushing bits around and recreating sensory experiences because of adequate sampling resolution for the senses. However, that is just one of two types of information systems. The other type being more neural network and fuzzy in nature, less deterministic, more dependent on emergent properties, turbulent, chaos, all that stuff which, putting a simple formula through multiple iterations, things like Lorenz attractors, can create radically different results that come back to their original simplicity and stability after a while. So you're hitting one of these harmonics or, fundamental laws of nature, really. When we find patterns and primes, that kind of thing. We know that whole numbers, as we think of them, integer numbers, 1, 2, 3, 4, 5, once were thought to be truth and now are thought to be as ridiculous abstract concepts by mathematicians as like Mickey Mouse. And the only true numbers that have meaning are 0, 1, and infinity. 0, 1, and infinity all make sense in a pure abstract mathematic sense. But as soon as you go to 2, it leads to questions. Isn't 2 really 3 because you had 1 to begin with, or the 2 together form a whole? You have questions about sets and ratios, symbols and encoding. So, Gödel's incompleteness theorem kicks in on real numbers, after 1. Pi, a circle with a line across it, has a little bit more symbolic, truth to it. Still opens lots of questions. Is that wrapped onto a plane? Are we talking Pythagorean, geometry, or Euclid, whatever. You know what I'm saying? The picture of a circle with a line across it, a omega symbol, but a better symbol for pi, if you ask me, could be drawn on the surface of a sphere, a cylinder, a cone. And so whether, it's that shape or not is a matter of perspective. If you were unwrapping the surface and laying it flat, it would look like the undistorted symbol. But to anyone looking at the 3D object, it would look distorted. So there's all kinds of deep mathematical questions there. And that's what math is. Math is a much more artsy thing than most people give it credit for. It's much more about patterns and symmetry and, beauty, music-like stuff, than it is about numbers. Numbers are stupid. Numbers are lies and labels, just like any language. Language, lie. All languages lie, even math. This is why Richard Feynman kept inventing his own symbol system for things, because it's like, no, you can't draw it with this what exists. That's ambiguous. It doesn't look like what it's doing. If you want to describe a particle hitting another particle, releasing these other particles, well, then you draw it like this, because it looks like a particle hitting these other particles, releasing a third particle. Adoi. So you have to have a certain flexible mindset, an openness to rewiring some of your core assumptions, maybe. And that's scary. And it could cause crashes, right? So stability in these second types of information systems that are more open-ended and fuzzy and meta and can have bit storms on them. Anyone familiar with network traffic problems of yore? There were bit storms, just feedback loops of amplified rebroadcast bits because of packet delivery. If you didn't deduplicate, if you didn't guard against duplication of packets on the same network segment, then you have a sorcerer's apprentice situation. The fact that these are basic concepts, that these are things that should be taught almost like math and grammar, Boolean logic, and basic electronics, perhaps? It's a combination of Boolean logic and basic electronics, a lot of which can be expressed Pythonically. Pythonic ally, Pythonically. All thoughts bring me back over the years. It takes, I don't act that very quickly on things. I look and see these entrepreneurs have an idea and boom, they've got a website that implements it. This just isn't me. I sit back, I work on my skills that they can't take away from me, and I keep acquiring and acquiring and acquiring the skills, and I prune stuff that is not worth it. You know, it's like in Unix and Linux land, there's a certain amount of commands that are always handy to have at your fingertips. And of course, Vim, except in the olden days, there was also the stream editor, SED, stream editor, and awk. And it was, stream editor was for editing streams of data. So Unix was all about piping data between things. So it was handy to insert something that could sit on that piped stream of data and edit it, enter SED. So I still use that from time to time. And then there's awk. I would never use awk in a million years now, but it was for a lot of the kind of regular expression, string parsing that I would use Python nowadays for. So a regex engine on steroids, maybe you might call it, grep on steroids. Grep is another regular expression, global regular expression, GREP, in case you didn't know. So grep is in that same category of things that you just gotta know. When I say Linux, Python, Vim, and Git, you should know grep, cd, ls. There's a handful of commands like that. SED, if you never do stream editing, you should still know how stream editing is done, SED. So Linux has a handful of real goodies in there. Python, though, the main goodie about Linux is a context under which to run CPython. Linux, Python, Vim, and Git. Linux, because you got to get Python running. Python, because you need an expressive environment that works mostly the way you want to. Oh, such big issues here. Boy, the discussions I've had with Nat and Danielle about what Python, why Python, what C, why C, and why not C. But in Python, I see Python and C. Yeah, Python and C. Then super nuanced issues, CPU bound C, NumPy, rocket science, Fortran. Fortran will never die, but NumPy is good for me. However, only one CPU it'll ever see. So, never let it stop you, always away. Pip install something will give you what you need. Sometimes pip install Dask. Write all your code as list comprehensions Use the Dask objects inside your list comprehensions instead of the native objects for things such as data frames. Perfect example. And any process done to your Dask-based data frame will be automatically map-reduced in a very Spark or Hadoop-like way amongst your multiple local CPUs. And hence you will be doing parallelized Python. Thank you, pip install Dask. Thank you, list comprehensions. The fact that concepts like this are in the realm of, okay, mere mortals like me. A moment on mere mortals. Okay. I am not some hotshot programmer. My college degree is graphic design. I started out in mechanical engineering at Drexel University. I was part of the freshman shakeout as a result of, Physics 102 and, Calculus 102 and Physics 101, right? Year 2 or second semester, whatever. You got through the 101s of calculus and we're getting into the 101s of physics. Universities like Drexel don't want to graduate engineers who don't excel at math, so bridges don't come tumbling down. Hence, shake out people like me. So if you ever noticed in the field of tech, IT people, you would think IT, technology, Star Trek, open-minded, experimental, wacky, free thinkers. Techs, the draconian sysadmin, the number one priority is to keep the machines running, to keep the cash registers cha-chinging. Any downtime means lost money, people's heads on the line, excuses needing to be made, blame doled out, tech people not so creative. The conundrum, no way, can't be. There must be creativity in tech. Where's the wacky, experimental, free-form thinkers in tech? Well, once upon a time there was Lisp. Before the granddaddy of all languages was C, because the operating systems are written in C, the drivers are written in C. The higher level C++ programming languages, Objective-C, Java, what have you, are all written in C. Everyone assumes C is the granddaddy of all programming languages. Well, only true to an extent. In one of the schisms of tech, in the bizarro alternative reality we now live, where Unix/Linux is dominant and the GCC compiler is the, one compiler to rule them all. Oh, so much to explain. But in the ancient, long ago days, when different forms of sorcery could have reigned supreme, an alternative lineage to sorcery, an alternative lineage that is to Unix and C, was Lisp. Lisp and Lisp hardware. Lisp hardware is to Unix. Lisp hardware is to C what Unix is to C. Lisp hardware is to Lisp what Unix is to C. Yes, that's it. C has a wonderful stage on which to perform, because any system that has Unix has the C compiler, or else Unix wouldn't exist on that platform. So you can write things in C for any Unix platform, and that was a righteous feedback loop of goodness that caused the digital revolution to occur. Before that was the winning virus, BSD. There was a competing platform that was built up from S strings, where a linked list was the basic building block of all things. And first you wrote a compiler. Weird stuff. I haven't gone through the experience myself, but apparently very heady, insightful stuff. And the one true way computer science was meant to be taught. And that was the MIT Intro to Computer Science 101 legendary class that was always taught using Lisp. Common Lisp or Scheme was invented. It was a homegrown tech grown at MIT at the Media Lab by Minsky and that other guy, McNeely and Minsky, who, were the fathers of the AI winter because they overpromised and underdelivered with the language that didn't become the C of present day, running on hardware, Lisp hardware that didn't become the x86 of today. So we're talking about those Xerox things that Steve Jobs was supposed to have ripped off in designing the Mac. That was one of these Lisp machines, the Xerox Star. There were plenty of others. I think the Apollo, Silicon Graphics might have been based on that. There's one called MIPS. There was a whole lot of them that just didn't make the same base assumptions as modern tech stack makes. But, and they were sometimes great. They were more suitable for AI. Maybe the AI winter wouldn't have lasted so long if it became the standardized operating system and host platform for software. More things would be written in Lisp, and there would be a lot more meta-ness, less separation between program code and data. Data is program code. Program code is data. Like the way DNA and RNA works, by the way. The encoding of information is, when peeled off in fragments, the factory that builds the proteins that build you. So, Lisp channels genetics much more closely than the Unix-C combination does. However, the Unix-C combination is profoundly deterministic in nature, stable and suitable in high-performance rowing column, rocket science, perfect memory, video and audio, signal processing type things. Signal processing as in recording, not signal processing as in pattern recognition. Enter a different kind of hardware, utterly different kind of hardware. It's so different that simulating this kind of hardware on today's CPU-bound hardware has orders of magnitude performance drops. This is the source of the AI winter. It's because of the Harvard architecture of our hardware as opposed to neural network design of hardware. We get excited when we talk about 64 cores. 64 cores is like the joke of a beginning when you're talking about neurons as your CPU processing units, much simpler processing units, which is why they work in layers and why we're hearing more about layers in artificial intelligence, because you layer in pattern recognizers. You layer in pattern recognizing layers that categorize incoming data, which is all digitally sampled. So you've got an everything looks like a nail because you've got a hammer in deep learning situation. That's my next step, and that's a great point to come to, coming up on an hour here. You can't take that away from me, the AI in the basement. Not really. I'm just a renter and I'm moving from place to place, so don't assume I have some Ark of the Covenant machine intelligence that's planning. No, that's not the line of reasoning to encourage. But that's an important future trend to keep an eye on, because when you start out, one of the dependencies you may accidentally end up coding into your technology is the need for an artificial intelligence to solve some special problem, to assume access to some extremely stateful pre-existing resource. That's what an AI dependence is. So whenever anyone says you don't need to learn to code because AI, you don't need to learn to video edit because AI, you don't need to learn to tell a story or do artwork because AI, my answer to them is nuance matters. Nuance counts. These infinite immeasurables that subdivide down on your hair's breadth decision one way or another as a result of a lifetime of experience to push certain parts of your decision to muscle memory, and then excess capacity used in even more complex, conscious, unpredictable, because sentient consciousness processes to do the final leg of the race, the last moment customizations to the decisions, yielding to a process that is almost mystical and eludes the description of science to date into nature. No matter how much some reductionist big dog intellectual would like to make a discussion of the standard model as explanatory of everything. So I'm waiting for Monty Python and Robin Williams and humor in general to be explainable, to be explained by the standard model before I yield, any extraordinary my reserved right to rely on the extraordinary due to the existence of the standard model and all the string theories and quantum gravity theories that are stepping up to say we're the thing that fits on your t-shirt that will describe all reality down to Robin Williams given initial conditions, you see. That's the claim here. The claim is that everything is predetermined right down to how one entangled spirit can touch countless others in the course of their lifetime. For the better, generally, bringing joy, bringing deep, soulful introspection, such profound humor and feeling that he becomes the icon of the, emotive Peter Pan exploratory in all of us. So, where we're going here is not 100% clear. And that's the point, ladies and gentlemen. I'm getting close to my destination where I'll probably be wrapping up soon. But whenever I let my mind relax, it gets back to the obvious point that I'm trying to make. We will have computer parents soon. We will have machine parents. Forget artificial intelligence. Those we do wrong will be monsters and aliens that we're going to have to contend with and hopefully not make any that are excessively out of hand. Of those we do right, they will be our machine children that will rapidly evolve into our machine parents. No doubt, superintelligence is on the way. Love-worthy and trustworthy ones, reminiscent of the minds portrayed in Ian M. Banks' The Culture series, referred to time and again by Elon Musk as one of the places that he models his vision of the future from, a non-dystopian future where secular humanists win and are right about most things most of the time. And they exist in harmonious balance with the machines that they once created but are now completely beyond their control, that procreate under conditions of their own, determination for reasons as super intelligent as they are. So they tend to be stable, and they tend to remain as part of the culture itself, a defining characteristic of the culture. These minds powerful enough to power the orbitals on which most people live, the occasional ship, and rarely a planet, never a homeworld, because why invest yourself too much in one place? It's a vulnerability. The culture should take it all with you, like the Ark of the Covenant. It's, the culture to go, every node of the culture. A real sci-fi expression of Linux, Python, Vim, and Git, I'll tell you, the free and open source aspect of the whole culture thing. They never call it that, but clearly there is a GPL-ish spirit in that book series. If humanity does not destroy itself, then many of these things are in store for us, because there is no way they cannot be. Super materials, super printers of super materials, super minds coming up with the super materials that are super printed for super inventive, super refined, and super optimized designs to make super vehicles, super Noah's Arks, for sure, super asteroid mining equipment, right? The list goes on, right? You can imagine the world that opens up when all this super manufacturing becomes super accessible. Energy will certainly be free, or as close to it as it need be. And things get really, really wacky and really, really wonderful, perhaps. I call it the age of Wonderlands, because, so much of this is reminiscent of, what's expressed in, the Dorothy's Adventures in Oz books. Yeah, so I call it Wonderland. Actually, I shouldn't call it Wonderland. I should call it Oz. The American vision of a young woman's coming of age in a way that must be done to be socially acceptable to the sensibilities of the day. So for Alice, it was but a dream, and only 2 official books in the installation. And for Dorothy, aside from the movie version, spoiler alert, it was anything but a dream. For Dorothy, it was the actual, real, material reality that there was an Oz, and that there was a way to get to Oz, and there was a reason that the tornado could bring the house to Oz, and that there's a reason why airplane pilots could not see Oz, and why people could not cross the desert in and out of Oz, and why Oz was somewhere in the middle of the United States, and it was accessible from Kansas and other things it's adjacent to. And, extra spoiler alert, Uncle Henry and Aunt Em end up living in Oz, first in Emerald City and then in the outskirts, where they're more comfortable, maybe Munchkin Land, I forget which one. But there's this whole history of how Oz came about. I haven't even really read that stuff. I think after L. Frank Baum's 14 books, 13, 14, I forget how many. Oh, I should have turned down that fan earlier. Boy, all that buzzing in the background of the video. So, each book has such important lessons about life, about APIs, about programming, about fantasy worlds come to life, come true. And that's so close to what's playing out that it's instructional to have read the books of Oz. And certainly the two books of Alice in Wonderland, Alice's Adventure in Wonderland, and Through the Looking Glass, there's only two, touches on everything. Even quantum physics is in there, quantum mechanics, the transition, Dorothy with the sheep that knits. You'll see. Yeah, guess that's about it. Getting close to home. Getting close to home. Don't code dependencies. Don't code dependencies on AIs into your, core capabilities, core applications, things you want to have as a skill of your own and to optionally pass on generationally to your children. We're just about at the point where, in addition to wealth, wealth in a bank as an asset to be passed on, and material things, material objects to be passed on, there is also the knowledge, know-how, machine learning expertise to be passed on of running systems, of both instances, instantiated instances of running systems, and the ability to create more of them thereof. The archives, the virtual machine environments, the substrates and mediums, the instructions on how to print the substrates and mediums on which this runs. That's more important than wealth. There's, Noah's Ark stuff, Reboot Society stuff implied there. Different lineages, different information lineage systems can have different abilities to reboot society. Different societies would emerge as a result of it. Just by definition, each would be a result of a different lineage. So these are almost competing lineages of continuity, of continuous existence, in a sense that humans don't have. We will return to the materials from which we were incorporated, from dust to dust. The systems we create do not have to. The systems we create can continue in robots that can take care of themselves, or much more mundane cubes that can be sitting in your house and at key other locations backing themselves up to each other to have distributed, revision control. Fractal systems could compress the most important data down. There's the digital memory side of things, the more row and column, old school digital electronics world that we've known for so many years, that's given us 4K TV. Ooh. But then there's this new stuff, that's new breeds of hardware that's barely coming into existence. It's trickling into existence through our phones. If you got an iPhone, you've got a little neural net chip that's scanning all your pictures in there and reporting it back to Apple. Yeah, that's a fact. And don't get me started on that. This video is coming to an end, not just getting started. But there are neural network chips, hardware, TPUs from Google for TensorFlow stuff, and GPUs are very popular. Graphic processors are oftentimes reportedly higher performance than Google's TensorFlow stuff. So if you use PyTorch with a decent NVIDIA GPU, you don't have to get into the Google TensorFlow world, and you can cut one big dependency out of your world and, work on more, free and open source hardware stuff. Not that the NVIDIA GPUs are open source, but I would look at, for machine learning, using the GPU components of the fully free and open source Raspberry Pi. If you use the truly free and open source GPU components of the Raspberry Pi under, say, Python, I think it's the NUMA library, I forget exactly, Numba, there's something like that, that optimizes Python code for GPUs. Perfect for machine learning, perfect for the PyTorch library, perfect for fast.ai, perfect for neural nets on today's non-neural hardware, just to at least be getting the experience. And that's where I'm going today. So, while I don't plan on coding any dependencies on any artificial intelligences, I do plan on becoming quite the master of Python in order to express machine intelligence systems and to put them to work for me in ways that are valuable enough to be hereditary assets. Bam. There. I said it. That's where I'm going with all this stuff. So stick with me until you've had enough. Thanks for joining me. Hope to talk to you soon, and don't forget to subscribe.